happy to host you today. Connecting the DOTs is so pleased to present Dr. Buzz Powell, who many of you have heard speak previously or know him quite well. He's quite a fixture in this industry, and I know has been a mentor and very influential for many. If you don't know him, he is the Associate Director and Research Professor at NCAT at Auburn University. And he comes to us today with over 35 years of experience in asphalt paving, technology, and innovation. And 22 of those years have been with NCAT. So he's going to speak to us today about NCAT's upcoming focus areas and what's on tap for the track. Before he begins, I just would like you to please remind you, please keep your phones on mute while Buzz is speaking, and we will open up to questions at the end of the presentation. And without further ado, go ahead, Buzz.
All right, well, I guess good afternoon, everybody. Some of us are in the central time zone here or farther west, but it's great to be able to spend some time with you today and talk about what we're doing here at the NCAT pavement test track. And the focus is going to be what's next for the 2021 research cycle, but I'm also going to kind of bridge the gap between the current cycle, which is 2018, and the next track that we'll build next summer. So before I get started on that, I wanted to get everybody on the same page regarding what is our mission here at the NCAT pavement test track. And as many of y'all know, what we really like to do here is help agencies make positive changes. It's very difficult for state highway agencies to navigate the change process, because when you make bad decisions, it can be extremely costly. So many of our agencies are change averse, and so we help them to navigate that change process. At the same time we do that, we really love to do innovative, relevant, and implementable research. Sometimes the change is very simple that we help the agencies with, and sometimes it's much more innovative and much more aggressive. But the bottom line for us is that our mission is, as many of y'all know, safe and sustainable asphalt pavements at the lowest possible life cycle cost. That's an all-encompassing thing to say, but to summarize it just a little bit better, we do research to determine what is the best combination of materials to put in each layer of the pavement structure. If you have the ideal materials in the mix and in the layers, then how much thickness do you need in order to minimize your life cycle cost? And then if you've got the right materials and you got the right structure, what do you need to do to preserve that? So, you build a good house, what's the most cost-effective roof to keep on the house? So that essentially is the three ways that we pursue safe and sustainable asphalt pavements at the lowest possible life cycle cost. This message has resonated with many state DOTs. We've, as Amy said, we've been doing this here at the track. We actually broke ground on the first track in 1998, so we've been doing this a very long time, and we've grown from being a track that was primarily a Southeastern Conference track to have a much larger impact. You see a lot of northern states in this sponsor slide. We actually have 24 state DOTs that fund research here at the track in partnership with several different private sector clients. But one of the big reasons why you see a lot of northern states on there, like Wisconsin and Michigan and so forth, is because now we have a strategic partnership with Minroad in several different areas that I'll go into here in just a minute. So we've grown through the years from 8 states to 24 states, and we're very grateful for our partnership with Minnesota Road Research Project that has made that possible. Now, Minnesota does a different brand of pavement testing than we do here on the NCAT pavement test track. This type of research is called accelerated pavement testing, where we do accelerated damage. So the idea with this in our 3-year project cycles is to take the middle 2 years and compress a design lifetime of damage, which for us, that's 10 million equivalent single axle loadings, approximately 6 million heavy axle passes. This is one of our vehicles that we run on the track, and because we don't have any bridge spans to collapse, we're not concerned about the high gross vehicle weight of this truck that you see on this slide. We need as many legal axle passes as we can safely apply per lap. So every axle besides the steer axles on this truck is loaded up to but not beyond the federal legal bridge limit. And that's an important part of our work, because the magnitude of the strain event, or the intensity of the load event, the magnitude of the load event on the track can affect the outcome of the studies. Mixes can perform completely differently at high strains than they do at normal strains. So it's important to us to use legal loads in the research that we do. The truck that you see on this slide, it's going to do about 400 laps a day. That's what we target. About 200 laps in a primarily AM shift, and then 200 more laps in a PM shift. We run 5 of these trucks at a time. So when we don't have any drivers out and we don't have any mechanical problems like flat tires and things like that, we run 2,000 laps a day. The track is 1.7 miles long. The straightaways are approximately a half a mile long. So if you do the math on that and throw in some downtime for drivers missing shifts and some mechanical problems, we run about 750,000 miles a year here on the track. And I think now we've driven over 9 million miles since we first started this research, since we started our first fleet operations back at the beginning of the 2000 research cycle, our inaugural research cycle. So the 2018 track that we're running right now, we're approaching 9 million easels, and this is the 7th research cycle. So in total, we've done about 69 million easels on the track since we started this research, and we actually have 2 test sections still on the track that were installed when we built that first research cycle. So a lot of really successful pavement performance on the track, and done a lot of good research for state DOTs with essential cooperation that we've got from industry, from material suppliers and equipment manufacturers, and from contractors. So we're very proud of that. Every week we park our trucks and we go out on Mondays and we do very detailed pavement condition assessments. Here's an example of the type of crack map data that we collect. This is a big deal to me personally, because at one time with Alabama DOT, I worked in research, and it's very difficult to do research on open roadways because of all the confounding factors that can influence the outcomes of the studies. And on the test track, the neat thing is all those confounding factors are all very controlled. And then we can park the trucks and go out and collect this kind of data in a very safe way that doesn't put any of our personnel at risk. So this is a snapshot crack map, but really what we're interested in is, when does cracking initiate, and then how rapidly does it progress? As you can see on this slide, this is a plot of the percentage of the total lane area cracked as a function of equivalent single axle loading. So this is one of our 10 million easel cycles. This is some data from a group experiment, multi-state group experiment that we executed back in the 2012 research cycle. And it was a really interesting study because we were looking at comparing a ground tire rubber focused section and a wrap focused section and a wrap brass focused section to kind of the all-American control section. And we actually had to rebuild the wrap focused section because it debonded between the base layer and the binder layer. And when we rebuilt it, it went from the worst performing section to the best performing section. So this is just an example of the type of work that we've done in the past, where all of the recycle focused sections outperformed the all-American control. And we also learned a lot about the need for tack and adjusting what was a specification ideal rate that we shot in the initial construction of that test section. We actually had to double that rate because of the various layers that we had built in this relatively thin pavement. The different colors of shading that I have on this slide correspond to the MAP 21 cracking criteria. So essentially, less than 5% of the lane area cracked is good, 5 to 20 is fair, and 20 or more is poor. So we're interested in how long the pavements stay in each one of those zones. but the state agencies are now under a lot of pressure with the federal government to keep their network outside of the poor conditions. So it's not just when cracking is initiated, but how rapidly it develops and how we can manage it and preserve that structure that is really important. So I wanted to give you a feel for what we're studying in 2018 in the current research cycle, and then transition from that with the sections that are going to stay in place for the next cycle, and then end up with a focus on the 2021 track that we're going to be building next summer. So in the current research cycle, as I said, we have a partnership with the Minnesota Road Research Project, and it's a two-part partnership where we're doing research with mixed performance testing, specifically cracking tests, fatigue cracking down south, and then thermal cracking up north, and then pavement preservation. So it's a two-way partnership where they're our subcontractor in the cracking test work. We're their subcontractor in the preservation experiment, noting that Dr. Adriana Vargas is the PI in preservation. So the whole objective of the mixed performance testing is which tests do the best job in predicting cracking. And we're talking about near surface fatigue cracking down here in our experiment, and then thermal cracking up north at the Minroad test facility on the mainline bypass. And this is really important because we need to know how to improve balanced mix design outcomes. We've been volumetrically optimizing our mixes for decades, and that we had a long history of success with that, primarily when we were using all virgin materials. That's not practical. You can't always build with virgin materials. We have to be sustainable with our industry. Our product with asphalt pavements is 100% recyclable, and when you want to use a higher percentages of reclaimed and recycled materials, then you really need to know how to assess that in the laboratory. That's important for state agencies in order to have sustainability, to implement sustainability, but also know that taxpayers are going to get the right kind of value for the investment that's being made in our roadways. And then contractors need to know that a BMD framework that they can complete their designs inside and build their roadways inside. So part of that, part of a BMD framework is mixed design approval, but then also construction quality testing. When we're approving mixed designs, there's some things that we want to look at that we don't have time to look at when we're actually building a roadway, but we need rapid turnaround tests when we're building a roadway so that contractors know, are they complying with the specification? And if they're not, what can they change fairly rapidly at the plant within the same day, within 3 or 4 hours in order to maintain specification compliance. And a big part of balanced mix design practices or methodologies is what type of aging you're going to use with the mix. You can do short-term aging to simulate what happens when you run mix through an asphalt plant, but cracking performance changes as mix ages over typically 4 to 5 years is the time frame that we're looking at. So we need to assess short-term performance because that's how we're going to be running our quality control tests. But agencies need to approve mix designs based on long-term benefits, and this is very, very important for recycling agents because when you go into the laboratory and you start doing long-term aging of mix, what you see is that some recycling agents sustain benefits, rheological benefits over a long period of time, and some other recycling agents do not. So they're not all created the same, and it's in the best interest of the agencies to consider that long-term aging, the effect of long-term aging on the performance of recycling agents. And really, this is all about sustainability of our infrastructure. And sustainability for me, I tell people all the time, is there's three P's of sustainability, or people and planet and profit. And we really have to have all 3 legs on the sustainability stool in order to have a successful infrastructure program. And we need to make the most we can of local virgin materials and then reclaimed and recycled materials. And if you look at what's happening with quarries all over the country, in some states, the number of active quarries is going down, and we're going to have agencies that are going to be really struggling to provide enough virgin material to build and maintain the roads in the manner that we need to provide infrastructure for our constituents. So we need to smartly use reclaimed and recycled materials in combination with the best locally available virgin materials. And most of the time when we talk about local virgin materials, we're thinking in terms of optimizing recycle content, but then also a lot of the work that we're doing on the track is aimed at maintaining surface friction when we have all of our, or many of our local aggregates, depending on your state jurisdiction. Maybe you have a polishing problem with your aggregates, and you only have a handful of sources in your state that provide really good friction numbers. Well, it's not just about blending virgin and recycle, it's about blending sources of virgin with recycle in order to provide for safe infrastructure. So all these things we are studying in the current research cycle on the track in various ways. And I'm going to kind of dig just a little bit deeper in this before I move on to the 2021 research cycle, which we're currently in the planning process for. So spending quite a bit of time here talking about this cracking group experiment as part of the partnership that we have with Minnesota. We have a list of tests. These are consensus tests that the DOTs that funded this experiment said we want to include these tests in our experiment. So we looked essentially at mix that would be mixed design type lab mix, lab compacted, with just plant simulation aging and then long-term critical aging, and then also mix that we actually ran through our plant to build test sections out on the NCAT pavement test track that have actually gone through the plant production aging, and then that we can do critical aging with. So we got 4 different categories of mix that we typically look at with each of these test procedures. And the objective of the study is to see which ones of these match up with the differences that we observe out on the NCAT pavement test track. So it's a very practical, real world experiment. And the test sections that we built for this, they're relatively thin, so they're bending a lot in response to these passing legal loads in our triple trailer trains. But the base layer and the binder layer were produced with very, very fatigue resistant, highly polymer modified binder. So they're thin, they're not going to crack in the bottom or the middle. What's different about these test sections is the top 1.5 inches. The top 1.5 inches is many different types of mixes that were set up to have a broad range of expected cracking performance. So the goal of this study is to see which ones of these lab tests actually predict the differences that we observe on the track. And we're doing the same thing up in Minnesota for thermal cracking. So very practical experiment, and there's a great product that comes for this from states that are in the southern United States or in the northern United States or somewhere in the middle where you have both fatigue and thermal cracking considerations. So if you look at what our correlations are, and this is after 8+ million easels, if you look at the cracking that we are mapping on the track, and you correlate that with the outcomes of these experiments, what you see is that for states that need to approve mixed designs, there's some really high correlation or coefficients of determination between what we're measuring in the lab and what we're observing on the track. So that everything I got highlighted in green, these are potentially good options that state DOTs can use to approve contractors' mixed designs for cracking performance. Now, there's the other side of balanced mixed design is rutting performance, but we have a lot of really good tools to assess rutting performance of mixes. Our big challenge is cracking performance. So everything I've shaded in green is a reasonable choice to assess and approve a contractor's mixed design. What I've got highlighted here in green is really the only test, in my opinion, that is a really good fit for construction quality testing that has a good correlation, and this is ideal CT testing. So it's just an indirect tension test. It's like a TSR test at a very specific sample height, and then instead of just peak loads like you would get from the dry side of TSR testing, you're looking at the shape of the curve to estimate or to assess whether a mix is going to be brittle or whether it's going to be compliant. You know, is it going to be crack resistant or is it going to be crack susceptible? And the ideal CT test is a very quick test, and you can turn results around in 3 to 4 hours. So when we do construction or maintenance work on the track, we always test drive ideal CT testing and hot IDT testing as a potential quality control tool. And I've just become more and more convinced over time that this is a great tool for agencies to consider for assessing the quality of produced mix. So again, for mix design approval, you got a lot of options for construction quality testing, where you need 3 to 4 hours of turnaround between the time you pull a sample and the time you get a number that can be compared to specification compliance. In my opinion, that's a short list, and it's ideal CT testing that does correlate well with what we see on the track. And that's without any kind of critical aging. That's just with plant aging. So then what happens when you take that plant mix that you can test rapidly during construction, and then you do subject it to critical aging? What's the relationship between just plant aged material and then the additional critically aged material? For us, critical aging is 8 hours of aging loose mix in a pan at 275 degrees Fahrenheit, and we know chemically that induces a change in the mix that is chemically very similar to what happens with age hardening and oxidation on a roadway for 4 to 5 years. So what you see in this plot is how do critical age numbers compare to just plant age numbers, or reheated plant mix in this case. And what you see looking at the slope of that line is that critical aging is about 34% of just plant aging. So remember what I told y'all about recycling agents, and you need recycling agents that where the chemistry, the rheological improvements are sustained over time. And this is a case, there are no recycling agents in this study. This is just plant mix with different levels of cracking performance. And critical age ideal CT numbers are about 34% of the mix that is just run through the plant. That's on the NCAT track, the southern half of our experiment. If you look at the northern half of the experiment, and these are mixes that we built at the Monroe test facility. We placed these mixes on the NCAT track in 2015. We placed them on the Monroe mainline bypass in 2016, and we've been monitoring cracking performance on these ever since under our traffic levels that we see. And at Monroe, the critically aged mix is about 45% of just the plant aged mix. So again, kind of regroup a little bit here. At NCAT, it's about 34%. At Monroe, it's about 45%. And you got different binders, you got different wrap, you got a lot of different things that are affecting this, but it's kind of interesting to see how that changed. This is data from another experiment that we did. This is for a state DOT where we tested some of their mix on active state projects. What we saw here was that critically aged mix was about 57% of just the plant aged material. So I think the takeaway from this is the quality of the residual binder that's in the wrap plays into this, and then also the virgin binder grade that is added to this mix when it's produced, it plays into that. So you're going to get a different reduction in ideal CT as a result of critical aging, depending on where the wrap comes from, where the state that the mix is being produced in, and whether or not you include recycling agents, and then how well those recycling agents stand up to the aging process. So there's a lot for us to think about here, but to kind of put all this together and view it through the lens of what we've seen here at NCAT, and this is based on our ideal CT numbers with and without critical aging, you know, in the mix design, and then what actually we run through the plant. And these are some possible CT index criteria for a state like Alabama. I'm suggesting these numbers. I'm not recommending these numbers to any agency, but I think it's a starting point for the discussion process for how CT index or ideal CT testing can be used to control the quality of our mix designs, as well as the quality of mix that's produced from those designs and placed on our roadways. So here what you see is you go from plant aging during the mix design process, possibly specifying an ideal a CT index of 50. That number goes down when you critically age it. So something probably 30 or better would be an arguable starting point. When you run mix through the plant, that 50 might drop to a 40, and then when you age that, when you critically age that, that might drop to a 20. Again, this is based on what we've observed on the track. If you applied these numbers really from our research that we've done here on the NCAT pavement test track, more or less represent a break point between a mix that's a really good performing mix, a mix that cracks later in its life versus a mix that cracks earlier in its life. So some DOTs are looking at numbers that are quite a bit higher than these, but I'm just kind of throwing this out here to facilitate discussion. And this I would suggest might even be applicable for a lower traffic level. So if you're an agency and you're trying to set up a performance optimized mix specification, then maybe you say, all right, that 50 is good for a lower traffic roadway, but for a medium traffic roadway, I want a contractor to design that for a 75, and maybe for high traffic, I want them to design that for 100. And if you design it for example, 100, then when you run it through your plant and it's been plant aged, then maybe my specification requirement is going to be an 80. And then if I take that and I do critical aging on it, maybe it's got to be at least a 40. And I'm not suggesting that these are the numbers that everybody needs to adopt. But if I put my Alabama DOT cap back on and I'm back working in materials and tests and writing and enforcing specifications with our materials here in Alabama, and then based on the performance that we've seen on the track, this would be a really good starting point to begin to work towards a specification requirement for CT index, I believe. So we also do a lot of work here in pavement preservation, and our pavement preservation work is actually impacted by our work with balanced mix design, because the thin lays that we've been placing in our preservation experiment going all the way back to 2015, all of our thin lays have been BMD thin lays, where we try to balance rutting performance and cracking performance, and still utilize the best use of RAP and in some cases RAS on these test sections. This is an aerial shot, a drone shot from Lee Road 159, and there are hot mix thin lay treatments, and there are emulsion treatments of different types, and then combinations of those. So we've got fog seals, chip seals, microsurface, cape seals, and thin lays, going all the way from virgin thin lays to 50% fine fractionated RAP thin lays. And what we're doing on these test sections is saying, okay, if the dash lines in this plot represent cracking performance without a treatment based on our control sections, the solid lines tell us how these sections are behaving with treatments. So, for example, this is a single layer microsurface, and if you look at when that pavement surface is in fair condition, the gap between the solid line and the dash line is the benefit that you get in performance from a single layer microsurface. And then if you look at that zone of this plot, what you see is that the fair and the good surface line up really well with each other, the solid lines, but when you put a microsurface on a pavement that's 20% or more of the total lane area cracked, then performance is significantly negatively impacted by that. So we are developing these standalone performance curves for different installations of microsurface that range from single layer with and without crack sealing to double layer, cape seals to high polymer to fibers and all kinds of different things. So there's a treasure trove of information in preservation, and you can actually download these cracking curves from the project website, which is pavetrack.com, PAVETRACK. You can also get to it from NCAT.us. So that's pavement preservation. Of course, we want to do preservation when we don't have deep distresses in a pavement, but we also do research on the track where we do have in place cracking, and we can't go all the way down to the bottom of the cracking to do a mill and inlay to get a new surface down. So for Georgia DOT, we're looking at different ways that we can prevent reflective cracking. So as you look at this slide, there are 2 plant mix options that are closest to you, 2 chip seals in the middle and 2 geosynthetics on the far end. The plant mix options, the one, if you can see my pointer here, I'm gonna try to pull up a laser pointer. This darker plant mix option, that's an Arizona rubber surface mix, very fatigue resistant, and we're using that to prevent reflective cracking. This is a plant produced open graded inner layer, much cheaper than the Arizona rubber with a non-polymer binder. And then of course we're putting the same dense mix on top of all of these. The 2 chip seals, this darker one is a coarse fractionated wrap chip, and the one right before it is a virgin aggregate chip. And then if you look at the opposite end of the study, you've got a fabric here, and then at the far end it's actually a geogrid and a fabric that's in combination. So Georgia DOT is looking at these 6 alternatives: 2 plant mix, 2 emulsion chips, and then 2 geosynthetics. And there was cracking already in this pavement that was saw cut, so that we knew exactly where it was. And we're just monitoring these pavements for the recurrence of reflective cracking. So stay tuned to the outcome of that experiment. But when pavements are now completely failed, so we talked about preservation and we've talked about preventive reflective cracking when we can't go all the way down and take care of the underlying cracks. What about when the pavement is completely failed? Well, for South Carolina DOT, we did a full depth rapid rebuild where we're putting 8 inches of warm mix asphalt down in a single pass. You see some of our strain gauges, our high-speed response instrumentation right here, so we can see how this pavement is responding to passing loads. But we did this. We successfully put this down over 8 inches in a single pass, and this is something that South Carolina is doing in failed interstate pavements and truck lanes, so that they don't have a big drop off as a result of staged construction. Our experience with this was that we did need to come back and diamond grind it. This was not unexpected because South Carolina has seen this. But as contractors in South Carolina get better at doing this really deep single lift placement of asphalt pavement, they're getting better and better with their smoothness numbers. And my understanding is now they're doing a lot of work that doesn't require any diamond grinding. And this is a huge deal because, you know, we're all taught that the thickness to nominal maximum aggregate size ratio needs to be 3 to 4. Well, what we found was that with a 1/2 inch nominal maximum aggregate size mix, we went all the way up to an 8-inch lift, and we cut cores and did density profiles, and we had excellent compaction in every layer. And we did run this as warm mix asphalt as well. So very, very successful experiment. Now, what all these have in common on the 2018 track, the reason why I'm kind of focusing on it now, is we do anticipate continuing traffic on all this stuff: preservation, the inner layers, crack prevention inner layers, and the full depth rapid rebuild. Those are going to be continuations in our next research cycle, which will be start next summer, the 2021 track, and that's part of agencies coming in and supporting these standalone experiments for each research cycle. So that's my segue to the next track. All that stuff that I just talked about, yeah, it's in the current research cycle, but it's going to continue to be in place for the next research cycle in 2021. We're continuing the Minroad partnership for mixed performance and for preservation. The mixed performance work that we're going to do with Minroad in the 2021 track is to quantify the impact of, quote, premium mix additives on pavement life. The shorthand for this is the additive group experiment, or the AG study, AG experiment. The product from this is going to be 93 design guide layer coefficients for states that do empirical pavement designs, and then calibrated models for states that are using the pavement ME system to design their pavements. So I'm mentioning this now because we're doing what we're referring to as phase 1 testing this fall, the fall of 2020, where we're doing balanced mix design work, we're doing mixed performance testing and modeling of many different, quote, premium mix additives so that we can present all those results to states that are sponsoring this study. All the states that are pitching in cooperatively to fund this study, they're going to, from all the phase 1 studies that we're doing, the states are going to choose which products that they want us to include in the track bill that we'll put down next summer. Of course, we'll build sections here in 2021, and then our expectation is that in 2022, with the 1-year offset, we'll put test sections down at the Monroe test facility so that we can look at the effect of their extreme thermal environment on all these same types of quote premium mixed additives. And then we expect an even greater focus on surface friction, a focus on tack options to provide good bonding between layers, and then cold recycle design. We've been doing cold recycle, 100% wrap cold recycle mixed research here since 2012, so for the last 8 years, and we think that work is only going to get bigger. So now we've done cold recycle sections on the track, we've done them off the track in our southern preservation test sections, and then summer 2019 we built 100% recycle sections up in Minnesota so we can capture that cold weather performance that we get up there. Surface friction is really a growing area of focus on the track, and the reason for this is agencies are becoming more focused on accident prevention in their jurisdictions, and they're dealing with dwindling virgin aggregate supplies that provide high friction or a good level of friction performance. So they're struggling with how do we use all the material that's available to us, virgin material and recycled material, natural aggregates, and even some synthetic aggregates to provide a safe roadway service for the motoring public. So we always talk about getting good life cycle performance out of our pavements. But if you build a pavement that lasts forever and it's not safe for people to drive on, then you really haven't done anything. So we have to consider safety as a very important part of sustainable pavements, and that's the reason why I presented the mission statement the way that I did in that early slide. So what this experiment is going to look like, this is kind of a schematic of it. The long name for the study is Sustainable and Resilient Pavement Technologies, shorthand SRPT. We're going to have a control section that's 5 inches thick on our base and our subgrade. And we know that at 5 inches thick, a pavement should last about 6 months here under accelerated traffic at our test facility. It's going to fail rapidly. That is the history that we have with these types of installations. So what we're going to do in the various treatment sections is build similar 5-inch pavements, but we're going to include fibers, some aramid fibers, possibly some other types of fibers, plastics of different types, maybe some epoxies, some recycled ground tire rubber type products, and then anything else that comes up this fall where a state says, hey, we want to take a look at this, or a vendor comes to us and says, hey, we want to fund one of these $20,000 small phase 1 experiments so we can generate modeling data that the states can consider to possibly include us in this experiment. Now for the future, I told y'all that the main product of this research is going to be a layer coefficient that you can use for pavement that's got recycled tire rubber in it, or for pavement that's got aramid fibers in it. But what about future products? We don't want to have to build test sections every time somebody comes up with a creative product that is intended to extend the life of pavements in a sustainable way. So the other big product of this research is going to be a laboratory framework that state agencies can use to subject products to predict performance. So it's going to be not just a cracking performance system like what we had in the last cycle. It's going to be a testing and modeling effort, so that a state says, okay, well, if I specify and invest in aramid fibers, instead of using my book value of layer coefficient or my conventional dense graded ME model, what effect am I getting from the fibers? How is it extending performance? Is it extending performance? And if it is it going to be worth the extra money that I spend on it? So that is of this additive group experiment that we're building next summer for the NCAT pavement test track. So key takeaways from all of this, NCAT stands in the gap for industry and agencies, and we're kind of that neutral party that industry likes to rely on us for innovation, and the agencies like to rely on us for technical support to navigate that change process. The nice thing about what we do is the track is ground truth for pavement performance. We're not using super loading to fail our pavements because that would produce confounded results because of those high strain magnitude events. We're using legal loads. We go to great lengths to have good construction quality so that doesn't potentially confound the outcomes. We know exactly how many axles have been applied. Climate's the same for everything, so it's very, very controlled. We're still engaged in this Minroad partnership. We don't really see an end to that because of the nationwide impact that it has. We really believe that when agencies approve mixed designs, they need to use plant and critical aging to approve their mixed designs. But when we're producing mix, we have to have a quick test where it's not going to be days or weeks before a contractor knows if a mix is good or not. They need to have rapid turnaround, so within the same day they can make a change in their production in order to maintain specification compliance. We have to know that the benefit of recycling agents is long term. If you just put a softener in a mix that you run, that's for example, a high wrap content mix. If you just soften the aged binder in the wrap for a short period of time, and then it age hardens very rapidly again, you're not going to get good cracking performance at that, as you approach that 4 to 5 year mark. We have to know that those benefits are sustained, and that quick turnaround is essential. I know some states that have done some pilot projects with balanced mix design, and they're using tests that takes weeks to get numbers back. That's not viable for implementation. If I'm a contractor and I pull a sample at 7 o'clock, I need to know before lunch, am I good on my cracking performance test, or do I need to use more recycling agent or more virgin binder or less wrap or reproportion my cold feed bins? What do I need to do to get back in compliance? So that quick turnaround is very, very important. And then, of course, in this cycle that we're planning right now, the key to it is, what is the performance impact of premium mix additives? If you use some of these materials and you pay money to specify these materials in mix, or if a contractor chooses to use some of these materials to satisfy BMD requirements, then is it going to pay for itself in the cost per ton impact and the operational impact at the plant? Is it going to be worth it? Well, we're going to be able to answer that question with this next research cycle and develop a framework that's kind of a NetPep style evaluation process for future additives as they emerge out there years from now. So a big part of what we do, as many of y'all know, is support for implementation, and we will be hosting our end of cycle conference for the 2018 track next April. We're have growing optimism that we will have turned a good corner, at least with the pandemic limitations. So where we ordinarily expect to have 250 plus people at this conference, the reality is you'll probably still have some state agencies that will be dealing with travel limitations. So where we ordinarily have 250 people here and maybe 40 people online, it might be a 50-50 split. But we are aggressively planning for a physical meeting, and it's going to be April the 20th through the 22nd here in Auburn, and we'll do tours of the track and get boots on the ground to look at the various test sections. And of course, the focus of this will always be implementation. So we would extend an invitation to all the participants in this meeting today to our track conference next spring. Well, there's my contact information, and I think we have a few minutes for some question and answer. Amy, if I'd be happy to answer any questions maybe that people have.
Absolutely. Before we start the Q&A, I just wanted to mention Buzz had discussed the Ideal CT as a reputable test. And if you're unfamiliar with that or would like more information, we had previously hosted a webinar by Dr. Fuji Zhao, who was instrumental in and with the Ideal CT. And I will put the link to that presentation if you'd like to see it into the chat section, where you're able to see that later, where all the rest of our webinars that we have hosted as part of the series, can be found.
And Amy, I would add that I looked at your archive, and I didn't go into any detail and burn any time on explaining what that test is, because Fuji is the brains behind that test, and I knew that he had already gone through that in a past webinar.
Yeah. Absolutely. No, thank you so much. I just wanted to mention in case some folks on the call had not been familiar. So thanks so much for that, Buzz. So we have one that I'm seeing coming through in chat that's asking whether you've evaluated the 8-inch deep warm mix asphalt placements for how long you need to wait to open them to initial traffic to prevent rutting.
We actually did. That's a very good question. And Dave Tim, who is our PI on our structural experiments here at NCAT, he is one of the development people behind, I think the name of the software is PaveCool, the pavement cooling modeling package. And a big part of building that section was, well, when we put that down, how long is it going to take that much mass to cool, and when can we put traffic on it? So we actually modeled that, and we placed it at the time of day that would provide us with the worst cooling conditions, or the longest term cooling conditions. And we didn't, we were still under construction at that time, so we couldn't put our trucks on it as soon as we put it down. But we were able to very aggressively consider the impact of cooling. And while we were able to get really good densities with the warm mix technology, we wouldn't have any problem at all as a result of that modeling effort, putting in 1,000 or 2,000 feet of this pavement overnight, and then taking the traffic control down and opening it to traffic the next morning. And that's what South Carolina wanted to do with this, as opposed to having staged construction with lane limitations and dangerous drop-offs. They wanted to be able to close and reopen interstate and just do complete rebuilds in 1,000 to 2,000 foot pieces. And we were able to demonstrate that is a good alternative for that. That's a good question, though.
One, Buzz, is any thought of using hot in place recycling?
Yes, we actually have tried to do hot in place recycling in various phases of research, and we thought we were going to get hot in place recycling in the Minroad recycle experiment that we built in the summer of 2019. It turned out that it was not possible to get that together, but if anyone is participating who is a hot in place recycler that would be interested in getting involved in what we're doing, we would love to talk to you about that, because we've not been able to get any test sections installed in the past, but we would love to do it.
Super. We had another question about the ideal CT, whether you could talk about the use of it on NMAS mixes over 19 millimeter.
I lost audio for a second there, Amy. What was that question again?
That's okay. That's okay, Buzz. Just if you could talk a little bit more about the possible use of the ideal CT on NMAS mixes over 19 millimeter.
That's a good question, because this is a test that has been developed essentially for 6-inch diameter specimens, for 150 millimeter diameter specimens. So we use it to assess small mixes and large mixes. Because it is a relatively large specimen, I think that it does have potential for the bigger stone mixes, but we do need to be very careful about where we set our expectations and our specification requirements for those mixes. And we certainly need to be really careful about the variability that we see with those tests. As a former specification writer and enforcer, we need to collect data. So one of the things that I talk about a lot is baselining our mixes. I think contractors need to be using the ideal CT test, because it's easy to do, and you can actually You can actually harvest data that relates to it from your TSR practices that you might currently be engaged in. And you should be assessing your mixes and figuring out what kind of numbers do I have, because your data that you can generate with your mixes, number one, will inform the specification process with the agencies that you do business with. And then number two, it'll give you a feel for how far you have to go to make your mixes perform better in that test. We need to be careful when you go to bigger rock mixes, because the rocks are gonna have potentially a confounding effect on the results. But we need data in order to understand that properly. The same thing's true for binders, by the way. If you're in a market where your binder loads as they come in might be from completely different base binders, or maybe you've got good consistent PG grades, but your supplier is doing some different things in order to achieve those PG grades. That's another good reason for you to engage in your own testing during construction, quality control testing, to understand how just natural variability in your binder supply may or may not affect your ideal CT numbers. You need to understand that so that when your agency goes to BMD testing, you're prepared for that.
Super. I know we're getting close to the hour, so if we have any more questions, if you will please put those into the chat portion of your screen, and we'll get close to rounding out our time together today with Buzz. In the interim, while we see if any more questions come in, I would just like to remind you that continuing education certificates will be provided for those of you who have attended today if you need them. So in the coming weeks, you should receive a certificate from our pavement team. And we appreciate you guys tuning in as we've leveraged some of the downtime due to the pandemic to be able to offer you even more webinars this year as part of our series. So I would encourage you to stay tuned for the final webinar that we will have this year. It should occur in November, where some of our very own mixed testing and design experts will be sharing some cutting edge research that is happening at Ingevity. I don't see any more. Actually, I do. We have one more, Buzz. It says higher percentages of RAP are good for our industry from a sustainability perspective, but how can agencies ensure that they're getting long-term benefits from recycling agents when they allow industry to use more RAP?
That's a great question, and that's really where that critical aging comes into play for mixed design approval. I didn't go into the detail on it, but if I was writing a specification for BMD for a state agency, and a contractor submits me a mixed design that includes a proposed recycling agent, I'm definitely going to do long-term aging on it, which is 8 hours at 275 of loose mix for the latitude where we are in Alabama for the solar exposure that we get. When you start the job and you're running your control strip, you can do critical aging on your initial ideal CT tests, so that the DOT can use that just like we currently use TSRs to make sure at startup, hey, that mix is not going to be moisture damage susceptible. We can look at your initial startup BMD results and say, yeah, that recycling agent is going to be sustainable. It's going to hold its own to get out to that 4 to 5 year mark. But during production, we need to do, after we get out of the control strip, we need rapid tests. And then you can go in and, like in Alabama, you can do 10 or 20,000 ton intervals and say, once a week or whatever, but we want to run a set of BMD tests that have critical aging attached to them, just so that we can make sure that we're going to have that sustained performance benefit that we know that we can get from the right recycling agents. But that's a great question.
Super. All right, we're hitting about at the top of the hour, so we're going to go ahead and close it out. Again, you can see a recording of today's presentation with any further contact information that you may need on our Connecting the DOT's website, which is connectingthegovdots.com. We thank each of you again for joining us today. Especially we thank you, Buzz, and please look out for information shortly on the last webinar in our series for 2021. This year. Have a great afternoon, and thanks again.
It was my pleasure, Amy, and it was great talking to everybody. Y'all have a blessed day.
Thank you, Buzz.